I'm Mark Farrell. I work at CSIRO, based at Adelaide at the Wake campus. I'm a research scientist there, particularly interested in carbon and nitrogen in soils. And we're here today to talk about cover crops. And there was a field site here that was conducted for 5 years as part of a national project where there were 20 sites around the country. This site in wonderfully lush Tasmania is definitely the wettest of them all. But yeah, we're here to discuss some of the findings. Tell me a little of what you thought of your initial thoughts about having been involved with the project.
Yeah, no, I'm Michael Nichols, so this is on our farm at Sisters Creek on the northwest of Tassie. We get 1,200 mils of rain a year, and yeah, I guess I did this trial for 5 years, putting in fallows, single species and multi-species covers over the 5 year period, going back into those exact locations each time with those with the fallows and multi-species and singles. And yeah, I guess we just worked through all the challenges and everything that sort of came from doing that with all the different crops, all the multitude of crops that we actually grow each year.
And that's a really big difference about this site relative to lots of the others, the sheer number of different species that are grown in these farming systems. And we were saying on the way down here that presented you some challenges with managing the stubbles and some occasions.
Yeah, absolutely. So like when we were planting our poppies and pyrethrum, which have really small seed, like probably half the size of a canola seed or even smaller, the multi-species and the single species covers sort of created a bit of trash, and little fine seeds don't like too much trash in the way, and we found that the germination was, substantially reduced, but also it did dry the top layer out, which meant that the seed obviously was a little drier than the fallows. But when it came to high rainfall events, like say we get 1,200 mils a year, we could have up to 200 mils in a month, and where we had big heavy downpours, you could see the fallows really were sheeting water off really quite badly, and it was sort of capping and everything, whereas the multi-species were just taking it really well.
So you reckon there was a real improvement in infiltration in the multi-species sites?
Absolutely, yeah. Definitely, and also just the nutrient that would have been held by the multi-species that wasn't going to be leached away from the fallow. Yeah, it was definitely a big indicator.
And in high productivity systems like that could be quite an important environmental benefit, right?
Oh, absolutely. Yeah, massive environmental benefit.
Yeah.
Yeah.
So just go over a few of the results now. So in the fifth year, we grew potatoes here.
Yep.
And yeah, being up front, there weren't massive differences in yield between the treatments. Nothing statistically significant. But looking into the soils data, there was actually quite a few interesting changes there that matched a lot of the other sites. So we saw improvements in microbial turnover of nitrogen, so that's your rate of nitrogen cycling and the rate it's released to the plant. We also saw increase in microbial biomass nitrogen, so that's the amount of nitrogen being held by the microbes, and that would be available within the growing season. Saw an tentative increases in carbon. It's difficult against such a high background anyway, but definitely not going backwards. And also quite big differences in fungal community structure as well, and here you could really see the difference between the single species as well as the multi.
Yep.
As with all microbial diversity data, it's a little difficult to tell the good from the bad, apart from outright disease species, but nonetheless pretty clear indication that there's functional differences occurring.
Yep.
In the soils. And one of the things that we saw at this site and at other sites, that increase in microbial biomass nitrogen, was really sort of showing that the microbial community is doing a good job of retaining that nitrogen in the profile where it would be available for plants, rather than leaving it in the nitrate form that is actually really quite lossy, and if you had a big rainfall event, it can be washed out of the system, as we discussed.
There was buckwheat, there was a mustard or a tillage radish, there was some peas, and there was some tama as I think there was 4 or 5 species. I guess one thing like the tillage radish made for some interesting work, because that could produce a massive big tuber, and then when you mulched that off, because we had to mulch all our cover crops because we just have too much biomass, we end up with these nice big holes in the ground that look like golf ball holes that go down maybe 4 or 5 inches, and that really does dry the profile out really quickly, which that's normally our biggest issue, is getting on the ground quickly, because we obviously get high rainfall. We definitely don't talk deciles, we talk about how dry it is. And hope it is dry enough to get on the ground. So so the tillage radish definitely allowed for quick drainage and drying it out.
That's an interesting point of notice talking to growers at many of the other sites, including some of the drier ends. The driest site we had was at Wakery, which is not far off a metre less rainfall than here a year. So not necessarily out at Wakery, but certainly at some of the sites, the site down on the Oaks Peninsula, for instance, and out in the upper southeast, sort of south of Keith in South Australia, where yes, lots of growers, particularly in those drier areas, were concerned about cover crops using moisture, but I also received plenty of questions about, that actually this might solve some localised waterlogging problems that they had on the site. So even in those drier areas, some of these considerations of moisture, but not in the most obvious way, actually are quite important things to consider and might be beneficial.
All in the one mix, and then we just had a mustard that was the single species, and then obviously just kept burning off the fallows because they kept coming back with weeds. The other component with having at least something growing means that at least you're getting that carryover of nutrient. You're not getting it leached away, especially in our circumstance with the high rainfall. The nutrients being tied up into that plant. When we're destroying that plant, it's getting then back re-released when we're then planting our next crop. So I would say that continuation of nutrient flow rather than having it being lost is probably another big consideration too.
And that actually ties in really well with some international research that I've come across. There was a really big study out of Europe published last year, and they had a transect of sites that went from southern Spain up to Scandinavia, so probably even a bigger rainfall gradient than the one that we covered from here over to semi-arid South Australia. And they had two findings, but the biggest of all was the amount of time the soil was under a living plant was the biggest driver of soil function and actually cash crop yield. The diversity of crops, and that might be between rotations as well as within rotation, the mixed species, that was an important but a secondary factor relative to actually the difference of plant or no plant. So that ties in really well again with findings elsewhere.
Your experience?
We've always grown cover crops on the property. I guess it was different trying to keep a fallow. I found that quite hard. But no, we grow a multitude of different cover crops. We grow some biofumigant mustards, which is just a single species. We've just been playing with some CSIRO oats, mainly because of the loading of pathogens that certain cover crops can create. We find that some, especially like the ryegrasses, can bring on rhizoctonia and powdery scab really badly, which would then affect our potato crops. And we found that CSIRO oats are one that don't seem to hold those levels, and they actually reduce them. So we've been playing with CSIRO oats, maybe mixing a few tick beans in to get a bit of nitrogen in there, because again they're a low host risk. But then we also grow some multi-species in front of, say, corn or poppies, where we do like a clover, a CSIRO oat, a mustard, tillage radish, some buckwheat, and just throw some sunflowers in because we can.
It's the North West Coast.
That's right, why not? And that always looks really pretty. It's always full of insects, whether it's pollinators or whether it's just ladybugs or lacewings. We just find that it seems to work, and we can also still use it as a secondary grazing crop for our beef cattle if we want to. We just find that it's quite a good one for holding soil structure.
And that's one thing I should mention there, the grazing aspect of it. I was out at a site that really hadn't had much of the rainfall that we've talked about, somewhere between Keith and Narracort in South Australia, and they really wanted to grow the cover crop primarily to produce biomass, but in the end they had a feed gap, and they were able to meet it with the cover crop rather than having to destock.
And also we find that the livestock seem to give you that other layer of fungal bacteria count, because obviously you've got manure going onto the paddock instead of just growing the leaf.
Yeah.
And we find that I don't know if it does anything, but it definitely seems to give you more diversity, I think, in the paddocks than if you don't graze them.
Yeah.
And some of the grazing might only be a very quick graze where you just take off. You might have 3 foot of biomass and you only take off half a foot from the top.
Yeah.
And that's just a quick grazing, so they're not actually destroying soil structure.
Yeah.
Otherwise, you can just make a boggy mess real quick.
Yeah.
Especially in our circumstances.
Yes.
Anyway.
Yeah. So I guess the only other thing is with doing a trial like this and getting some pretty cool results out of it, does that just encourage you to keep doing what you're doing, or does it make any changes in your system?
No, I think that having some sort of cover after your main crop is always a good thing, whether it's for wind erosion, soil erosion through too much rain, or just a general holding of nutrient for the next crop.
Yeah.
And the other thing I'd note is that we always find that we produce too much biomass, and sometimes getting the next crop ready, so you've always got to be probably 8 weeks thinking ahead of where you want that paddock to be, so you might have to spray it off. The other thing we've done is bought a very nice mulcher, so we can actually mulch everything to an inch of its life, so it will break down a lot quicker.
Yeah.
Because again, we're growing crops that we need to tillage the soil with, and we find if we've got too much stuff there,
too much bulk,
things just don't flow and block up and create an issue.
Any surprises from the results?
No, I think they just reinforce the fact that it's worth doing.
Yeah.
Yeah, and I should say those results are fairly cohesive. They're really showing the same pattern that we've seen at several of the other places and also in the literature.
Yeah.
And that really it is a case of feeding the system rather than just feeding the crop, and that really sort of fits in with that ethos.
Yeah.
So slowly improving carbon, improving microbial use of nitrogen and recycling of it, and really just making the system a bit more resilient.
Yeah.
Yep.
Good
And
for you.
the other thing is that sometimes the cover crops only have to be a weed. They can just be a weed bank growing.
Yeah.
Is enough. Like something after like X poppies, when you've mulched the crop, you end up with this beautiful strike of poppies. And obviously before when they get 3 or 4 inches high, you then burn them off and plant your next crop, but at least you don't have to actually source the seed for that. Wheat's another one, barley's another one. They just comes back very quickly.
And provided you managing that from a disease management perspective,
that's right.
There's absolutely nothing wrong with that. There's entirely different part of the country, up in cotton country at Narrabri, Lake Rocky Rochester's long-term trial up there famously had the weedy fallow, where he'd had, this was grown, of course, cotton's a summer irrigated summer crop, so grown in winter and could be up here in really fertile soils. But of course there's reforming work done on those paddocks every year ahead of establishing the cotton. And basically a free cover crop.
You
Just need to be careful. There's nothing really
Dangerous.
at risk in there,
And
but it's not. And that's exactly right. And that's an important point to emphasise actually, that because one of the questions that I quite often get when people think about cover cropping is, well, aren't you just creating a big weed problem for yourself? Well, if you get the termination right and get it effective before flowering and seed set, then there is very little risk of you creating a weed problem for yourself.
Yeah, absolutely.
If you can get on field.
If you can get on field.